How to find Pythagorean triples in geometry. Imagine you have a right triangle and you want to find side lengths that fit perfectly together. Maybe you want to build a model or solve a puzzle. Knowing how to find sets of 3 numbers that work is really handy. That's where Pythagorean triples come in. They are groups of 3 positive whole numbers that follow the Pythagorean theorem. This theorem says that in a right triangle, the square of the longest side, called the hypotenuse, equals the sum of the squares of the other 2 sides. The easiest way to start is with the most famous triple, which is 3, 4, and 5. Because 4 squared is 16, 3 squared is 9, and 5 squared is 25. When you add 9 and 16, you get 25, which matches 5 squared. This confirms that 3, 4, and 5 make a Pythagorean triple. To find more triples, you can use a special formula. Pick 2 positive numbers called m and n, where m is bigger than and then you can find the sides of a right triangle with these formulas. The first side is m squared minus n squared, the second side is 2 times m times n, and the hypotenuse is m squared plus n squared. For example, if m is 3 and n is 2, then the first side is 9 minus 4, which is 5. The second side is 2 times 3 times 2, which is 12. And the hypotenuse is 9 plus 4, which is 13. So 5, 12, and 13 from a Pythagorean triple. Another way to get more triples is to multiply a known triple by any whole number. If you multiply 3, 4, and 5 by 2, you get 6, 8, and 10. These are also Pythagorean triples, but they are not primitive because they all share a common factor. Primitive triples are those that cannot be divided by any number other than 1 without leaving a remainder. To check if a set of numbers is a Pythagorean triple, just square the 2 smaller numbers, add them together, and see if the result is a perfect square. For example, if you have 7, 24, and 25, you square 7 and 24, which gives 49 and 568. Adding those gives 597. Since 597 is not a perfect square, this set is not a Pythagorean triple. Finding these triples is useful in many areas of geometry and construction. It helps you quickly identify right triangles with whole number sides, making measurements easier and more accurate. Remember, start with the basic triple, use the formula with m and n to generate new triples, and always verify your solutions by checking if the sum of the squares matches the hypotenuse squared. This method makes understanding the relationship between the sides of right triangles much simpler and more fun.